So now the third class that we talk about is SP, standard power, SP class. Now these rules apply. The SP class is the one we're probably most familiar with because that's up to 36 dBm. So that's some power levels that are very familiar to us. But in order to use that, we need to use something called AFC, automatic frequency control. And so we talked about that in a previous webcast. But let's summarize that a little bit here. Mitch, what is an AFC system going to do? Why does an AFC system, what's the purpose of an AFC system, first of all? Why is it there?
Well, the purpose of the AFC system, go on.
And answer one more question. So why is it there? And tell me why it's better. Why is it better than what we're doing today with 5 gigahertz DFS? 2 questions.
Okay, 2 questions. So first we'll start with why, right? Well, it's not like the 6 gigahertz is not being used by somebody. I mean, in Wi-Fi, it's a greenfield, but in use in general, it's not. It's used for long haul point to point. It's used for streaming in television from mobile locations back to the main station, and it's used in the satellite from Earth stations to up to the satellite. So I mean, it's already used by something, right? These people have paid for licenses, they paid for the use of it. So we've got to kind of help coordinate, because I mean, they paid for it. They deserve just the same right as us to use it. So now we have, automatic frequency control. And this automatic frequency control says, hey, I know you want to in our case of our Wi-Fi, right? I know you want to operate on this channel, but there's an incumbent in this geolocation, right? Because FCC does things by location, by Latin long, so that they know where each transmitter is at. It says, well, you can't operate on this station. You got to move over to here, right? So there's a little bit, there's a lot of coordination in the sense of allowing the incumbents to freely transmit and not be interfered with, as well as our network to be freely transmitted and not to be interfered with, right? Because we would be interfering with each other if we didn't have this. And so that's really what that AFC provides us. And you kind of brought up that DFS channel, right? In the 5 gigahertz, they opened up some more band, but that was also utilized, but we didn't really, we kind of worked on an honor system, right? So if I heard somebody else transmit on that, then I need to move. And really, one of the big utilizers of the DFS channel is our, the weather radar, the Doppler radar, and some of the radar that's used at the airports. So if we heard that, they weren't going to move, we're going to move, right? The Wi-Fi is going to move. So we moved, which meant that the clients got upset because now we got to go find a new channel to be on with you so we could keep talking, right? There was really, like I said, it was an honor system. I promised I will move if I hear that interference, right? Whereas this one is, no, I'm not even going to let you operate there if there's a possibility of interference. So it's a much more coordinated effort as opposed to the honor system, and it will create a more stable network.
I like that. Another thing about DFS that was a failure from I always worked at a hardware vendor, but I also did lots of field deployments. The challenges in deploying that technology is the access point now has to listen to these pulses of radar that are happening in microseconds, which is not a normal time frame that an access point deals with. So it has to deal with these very, very small micropulses of radar. It has to detect it, try to determine that's a radar signal, and then it has to do that scanning for 60 seconds, a whole full minute per channel before it can actually access that channel. So all of those rules led to an honor system, but also led to a lot of false triggers. Maybe it saw some radar, so it bounced off to another channel. All the clients had to move over, and maybe that channel really was clear. Maybe it was a false positive, and so it led to a lot of false triggers on radar, whether they're really there, and also a lot of missed triggers as well. Again, because of that short pulse duration of a radar signal, so it made it very difficult to actually implement DFS consistently. So I like AFC. With the AFC, as you said, it's a deterministic set system. where the regulatory domain knows the geographic location of the incumbent user and just simply tells the AP what it can and can't do. It's very simple. You can use these frequencies, you can use this power level. So SP class. Now, SP class will be allowed to be used outdoors and indoors under this control of this AFC system. Outdoors, probably higher likelihood of interference, right? Because it's not going to be restricted by the building construction. So definitely when it comes to outdoor networks, SP class is going to be really needs that AFC system. It's going to be very, very important. LPI, low power indoor. The word indoor is the key word there. Literally means indoor only. LPI is no license required. You can use the entire 1200 megahertz as long, and the access points will already be programmed to obey those access rules. So LPI will be, in my opinion, the most widely used of these modes.